So good morning, sir. This is our code walkthrough of NFA to DFA Conversion Simulation. So I define the state here so that I can call this object to hold its name and the input, uh, so that I can use it to be the key of my transition table later on. And there are only three global variables that I will be using, which are the states, the name of the states, and the tra- transition table, and I used a hash map for this. So the program assumes that the user knows how many states that it is going to use, and the user knows what language this automaton will accept. So in the create states, it already takes a variable input, an integer variable input that will be used to create that amount of states. And this is just basically the input that this program is allowed to accept. And I appended the epsilon here because NFAs can accept epsilon. And this is just the creation of everything, of every state. This is the loop that creates all the states. It is incremented starting from the zero and so on and so forth. And I had to actually clear the inputs that is associated with all the states because I have initialized it as none, and I had to clear that up. And then after that, the program goes into the loop that takes what input is it going to take, and after that, if the input is recognized, it will be trying to add the transition from that state to another state, which is called by this add transition function. The add transition function takes the state name, and that will be the current state, and the number of states, um, to call at least how many times will it take an input, and of course the user accepted input, which we which we, which we took here earlier. Now this is a while loop. It prints the current state, and then asks where does this go if we took that input that we acquired earlier, and if that state is recognized, then we put that in the transition hash function. I mean the transition hash map, which is basically structured like this. If we had a key of Q0, then its value would be another hash map, which would be this user accepted input. Let's say we got A, and this A would have something or some state that it will go to once we got A. So let's say this goes from Q0 to Q1, and this would be its structure. After that, if we have um, if we have finally assigned all the transitions that we needed for the language that is specified by the user, then we try to convert that into its corresponding DFA. And before we do that, we have to get the epsilon closure of that state, of the first state. Epsilon closure is basically just taking all the transitions from the current state. Let's say we have Q0, and we take all the transitions that involves it epsilon, and just append that on the current state. Let's say if q0 goes to if q0 gets epsilon, and this epsilon takes it to at least, let's say, q1, then this epsilon closure will return q0 and q1 as the new state. That is how it's going to do the epsilon closure function. After we get that, and we are sure that this is the only epsilon closure that we are only ever going to get, then we try to convert that NFA to its corresponding DFA. And we need two parameters here. We need the input, which is basically what we had earlier here, this one, and then the transitions hash. This transitions hash is basically the NFA that we have constructed from the functions above. So the DFA start state is actually a frozen set because, as one of my classmates said, I did not have a hash function that is specified for the object that I am trying to call. So this is frozen set, so it can be hashed because objects are immutable, and that made it work. So I used it. So we get the epsilon closure of the first state Q0, as it is always the start state, and we check if there are any epsilon transitions in the transition table. And the DFA states basically just takes note of every state that we have processed so far. And because we already have processed the current state together with its epsilon closure, then it should be noted that it is already processed, it is already discovered, and now we go to the unprocessed state. The current state will be assigned with the value that we have. Um, let's just say it like this: the unprocessed states is a stack that will be assigned all the states that we have not yet processed, of course, and the current state um, will be acquired from that state by using the pop function. And after that, we have a DFA transitions to make the transition table for our corresponding DFA. And since, as I've said earlier, the transition table is structured like this, then since we are right here already, this is what we have so far. The key and its value would still be an empty frozen set. And now we have to check for every symbol that we have placed in the input variable. And we have to take note of what more NFA states we have not yet discovered, and we add another for loop into that. And this is basically just saying that for every NFA state in the current state, by way of transition function, the transition table, we try to get the what do you call this? We try to get the state and the symbol, and where it goes with that symbol, and we update the next NFA states so that in the next loop we will be going to that state instead. The new DFA state. Of course, we also have to assign a new value to that because now we have discovered another DFA state. And if new DFA state is not yet in the DFA states that we have discovered, then we also have to update that. This remember that this variable DFA state is outside of this loop, and then we have to also append this new DFA state to the stack so that on the next loop we will be going into that instead. And after that, it basically just creates another instance, which, as I've said earlier, will always go like this. The key would be the current state, let's say Q0, and for A, it goes to Q2, and it will return this. And this check string is basically just, checking the string, and it will return either true or false if this transition, let's say we have AAB, we are basically just checking that for every symbol of this, we try to see if the last symbol would give us the final state, and if it's not, then we just return false. Let's try doing that. What do I do? Let's try to create a automaton an NFA automaton that accepts any string that ends with B. Let's try with that simple one first. So we define the final state, we define the user input, we place it in the create states variable, I mean the function, and then let's see what happens. Let's say we have a 4 that goes to Q0, epsilon goes to um, Q1, and then let's say Q1 goes to, I mean Q1 with input B goes to Q2, and then that's just all. And let's say Q2 input A goes to Q2, B goes to Q2 as well, and let's see how that looks like. Wait, something, I think it was bugged. Wait, 0.